In this video, we will take a look at the equation of a circle. So to derive the equation of a circle, we must know the distance formula, which we have covered in a previous video, and we want to know the distance between 2 points, hk and xy. So the distance between those will be subtract the x's, so the second x minus the first x, quantity squared, plus the second y minus the first y, quantity squared. Then we take the square root. So what is a circle? What we have here is the locus of points definition of a circle. And whenever we are discussing locus of points, it just simply means collection of points. So what is a circle? A circle is simply a collection of points, x, y, that are a fixed distance r from a fixed point hk. So a fixed point is a point that does not move. So hk is not moving. It's called the center. R is our fixed distance. It's called the radius. And xy, it is any point that is a distance r from this center point. So xy is not fixed. It could move as long as it satisfies the requirement that is the distance r from hk. That being said, we know that the distance between xy and hk from the previous warm-up is given by this expression. And we are told here that the distance between these 2 points is r. So if we square both sides, we get what we know as the equation of our circle. X minus h, quantity squared, plus y minus k, quantity squared, equals r squared. So let's state this formally. The standard form of an equation of a circle that has a radius of r and a center hk is given by this equation. And this is something that you will need to memorize. X minus h quantity squared plus y minus k quantity squared equals r squared. So notice the center is given by hk and the radius is r. So let's take a look at an example. We want to find the standard form of the equation of a circle, and that circle has a radius of 5 square roots of 2, and the center is 2, 3. So let's just plug in these values. So x minus h, quantity squared, plus y minus k, quantity squared, equals r squared, will become x minus, now the center is 2, 3, so that means h is 2, and k is 3. So x minus 2, quantity squared, plus y minus 3, quantity squared, equals, now we need to square the radius. So 5 square roots of 2 squared. So we have x minus 2, quantity squared, plus y minus 3, quantity squared, and to square 5 square roots of 2, we square the 5, we square the square root of 2, and get 2. And so our circle's equation in standard form is x minus 2 quantity squared plus y minus 3 quantity squared equals 50. By far the easiest way to use the equation of a circle is whenever it is in standard form. But sometimes we are given an equation that is in general form. So the general form has the squared quantities first, and then in alphabetical order we see the x's and the y's, and then we see our constant. So let's go ahead and write the general form of an equation of a circle that has a radius of 6 and a center of -1. 2. So r is 6, h is -1, and k is 2. So we know that the equation of our circle is going to be x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. Let's substitute these values in. X minus -1 would be x plus 1, quantity squared, plus y minus 2, quantity squared, equals 6 squared will be 36. Now, to write our equation in general form, we need to take our equation and just simply expand the binomials. So x plus 1 quantity squared will be x plus 1 times x plus 1. And y minus 2 quantity squared will be y minus 2 times y minus 2. So if we FOIL those out, we will obtain x squared plus 2x plus 1 plus y squared minus 4y plus 4, and this will all equal 36. Now, we need to write our squared terms alphabetically, and then our x's and y's alphabetically. So x squared plus y squared plus 2xy minus 4y, and then we have plus 1 plus 4 will be plus 5, and this is equal to 36. So now we just need to move the 36 over so that one side is equal to 0. So x squared plus y squared plus 2x minus 4y minus 31. Here we are given an equation, and it is almost in standard form, and we are asked to find the center and the radius. So let's go ahead and get it in standard form, and you'll notice that the thing that is preventing us from being in standard form is simply this 4 in front of each one of these squared binomials. So let's divide every single term by 4. This yields for us x plus 6, quantity squared, plus y minus 2, quantity squared, equals 2. So remember that the standard form of our equation of our circle is x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. So what is being subtracted from x in order to get x plus 6? So that would be much like x minus -6, wouldn't it? And so h will always be the opposite sign of what you see with x. So -6 is h. So h equals -6, and then it's a little bit clearer to see that k equals the number being subtracted from y, and then r is going to be what? Well, r squared is 2, so we are going to look for the positive square root of 2 because r is a distance. We will only deal with the positive square root. So this means that the center is hk, so -6, 2. The radius is r, so it will be the square root of 2. Now we need to find the intercepts, if there are any. So, how do we find intercepts? Let's look first at the x-intercept. To find the x-intercept, that will be where it intersects the x-axis. That would be where y equals 0. So let's go to our original equation and let y equal 0. So we would have 4 times the quantity x plus 6, quantity squared, plus 4 times 0 minus 2, quantity squared, equals 8. So this means 4 times x plus 6, quantity squared. Now, negative 2, quantity squared is 4, so this will be plus 16 equals 8. We can subtract 16 from both sides. And then we can divide by 4. Oh, I forgot my squared. So this will be negative 2. Now if we take the square root of both sides, we will get plus or minus the square root of negative 2. Now we can stop there because this is not real. Since this is not real, there are no x-intercepts. Now let's look for any y-intercepts. So since the y-intercept is where we cross the y-axis, that would mean that x would be 0. So let's let x equal 0, and we'll follow similar steps as to what we did previously. We'll have 4 times 0 plus 6, quantity squared, plus 4 times y minus 2, quantity squared, equals 8. And this would give us 6 squared is 36, times 4 is 144, plus 4 times the quantity, y minus 2, quantity squared, equals 8. And so then, if we subtract 144 from both sides, we have negative 136. So we have y minus 2 quantity squared. If we divide both sides by 4 now, we have negative 34, which is not real. So we have no y-intercepts. Here we have an equation that is almost in general form. Notice the coefficients of x squared and y squared aren't 1, they're 2. And we want to write this in standard form so we can identify the center and the radius. So let's go ahead and divide everything by 2. So we're dividing every single term on both sides by 2. So we have x squared plus y squared minus 8x plus 6y plus 13 equals 0. Now, let's group our x's together. So we have x squared minus 8x plus y squared plus 6y, and let's move the 13 to the other side. Now, our goal will be to create a trinomial square for the x's, and then also a trinomial square for the y's. So, what can we add to the x's in order to complete the square? So, we take the negative 8, divide by 2, and square. If we take negative 8 and divide by 2, we get negative 4. Square it, and we get 16. Now, if we've added 16 to one side, we need to go ahead and add 16 to the other. And now, if we look at our y's, we have 6y. What can we add to y squared plus 6y in order to get a trinomial square? We take the 6, divide by 2, and square. So 6 divided by 2 is 3. Square it, we get 9. So we will add 9 to both sides. And so now we have a trinomial square for the x's. This will be x minus 4, quantity squared. And then y squared plus 6y plus 9. This will be y plus 3 quantity squared. And notice these two are added. And then on the right hand side, negative 13 plus 16 plus 9 equals 12. So this means that h equals 4, k equals negative 3, and r is going to be the square root of 12. But that is 2 square roots of 3. So this tells us our center is 4 comma negative 3, and the radius is 2 square roots of 3. Now let's find the intercepts, if there are any. So to find the x-intercept, we're going to let y equal 0. And if we're going to let y equal 0, I'm going to focus in on this equation. We could use the original equation, that'd be fine. But this one's simplified some. So if we let y equal 0, we'll have x squared, then y squared will be 0, minus 8x, 6y will be 0, plus 13 equals 0. This does not factor, so let's go ahead and use the quadratic formula. X will equal negative b plus or minus the square root of the square of b minus 4 times a times c. And this is all over 2a. So this gives us 8 plus or minus the square root of 64 minus 52, which will be 12. And this is all over 2. So 8 plus or minus 2 square roots of 3 over 2. Now we can factor out 2 from our numerator. And we obtain 4 plus or minus the square root of 3 for the x-intercepts. Now let's look for our y-intercepts. We'll let x equal 0. Going back to that same equation, we will just take this and we will let x be 0. So x squared will drop out, 8x will drop out. We'll have y squared plus 6y plus 13 equals 0. So y squared plus 6y plus 13 equals 0. Again, this does not factor, so we'll write our quadratic formula. Y equals, this time, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we get negative 6 plus or minus the square root of, that will be 36 minus 52, which is negative 16. And that's all over 2. But we can already stop because we're taking the square root of negative 16. This is not real. So there are no y-intercepts.